So we have an asymptote here, and underneath this I'm just going to write y equals b to the x. The inverse of that doesn't have 0, 1, has 1, 0. Doesn't have 1b, has b1. Doesn't have an asymptote at y equals 0, has an asymptote instead at x equals 0. It's not the equation y equals b to the x, it's the equation x equals b to the y. But we always have to solve for y, correct? When you write an inverse, you switch the x's and the y's, but you have to solve for y. So here is where the log comes in. Because I have to solve for something that's in an exponent. So I have to log both sides. Specifically, which log do you want to take? Do you want to take plain log? Log with a different base? Log base b on both sides. That'll have those cancel, so your equation will be log base b of x equals y, and that is the log parent graph. So that's all of it in a nutshell. You've got your exponential parent graph, your log parent graph, and when you switch the x's and the y's and solve for y, you can see y. They're reflections of each other. If we were ever to put them on the same graph, they're reflections of each other over this diagonal. Exponents undo logs, logs undo exponents. They're inverse operations, they're inverse functions, okay? So this one has us exploring the graph of log base 3 of x. So given what we kind of already know, we should know that there's a critical point at 1, 0. There's an asymptote on the y-axis, and there's a critical point at b1, which in this case is what? 3, 1. And the shape of the graph is always consistent with the parent graph. Now, a table of values is trickier for a log function because picking the x's is not a good idea. What's the translation of y equals log base 3 of x into an exponential equivalent, Isaiah? Nope. Nope. What's the translation? I'll tell you what, it was the last question on the quiz corrections you just handed in. It's the base of 3 raised to the other side, y equals x. That's the exponential equation equivalent to that log equation. The base of 3 raised to the other side, y equals x. So when you're doing a table of values for a log graph, it actually makes sense because of this to pick y values. A y of 0, a y of 1, a y of 2, a y of -1, a y of -2. What is, we'll start with 0. What is 3 to the 0 power? 1. So our x is 1. What is 3 to the first power? 3. Well, there are two critical points, 1, 0, and 3, 1. 3 to the second power? 9. 3 to the negative first power? No. Negative exponents don't make negative numbers. Negative exponents make fractions. 3 to the negative second power? 1/9. Okay? So this is having us go the other way. Write the equation of the inverse of this. Well, first of all, switch the x's and the y. And solve for y. Well, to solve for y, I need to use my translation to get it out of log language and into exponential. So it would be the base of 3 raised to the other side equals y. And guess what? Y is already by itself. So the inverse function is the exponential with a base of 3 versus a log with a base of 3. Good? So this parent graph, just so we have it in front of us, is exponential growth or decay? Growth. So it's just going to look like that. So with y equals 3 to the x, now that we're looking at it, exponential parent graph, our domain is negative infinity to infinity. And our range is from a y value of 0, not including 0, to infinity. And our log parent graph domain, now that we're looking at it, the furthest left it goes is 0, but not including it. To the furthest right it goes is infinity. And then range, the lowest it goes is negative infinity. The highest it goes is infinity. So what do you notice about the domain and range of the exponential and the domain and range of the logs? They're flip-flopped. That's what happens with inverses. Okay? Now, the natural log of x graph is still log base e of x. So it's still a log graph. So we still have the point 1, 0. And we still have the point b comma 1, but b in this case is e. So that's 2.7-ish comma 1. Or e comma 1, whichever way you want to label it. Same asymptotes. Same domain and range as any log graph. Domain is from 0 to infinity. Remember the fact that we can only take logs of positive numbers? Right? That's reflected in this domain. You can only plug in positive numbers. And your range is negative infinity to infinity. Okay? Flip that over. Here's a log graph that has undergone some shifting. This option 1 would mean it's been shifted left 2 and down 1. Well, you typically have a critical point at 1, 0. So if 1, 0 got shifted left 2 and down 1, we would see a point right there. So is that what happened? Here's 1, 0 on the parent graph, left 2, down 1. Is that where that new point is? No, so that's out. This one would have gotten shifted right 3 and up 1. Let me go. Right 3 from that parent graph critical point. If you want to sketch the parent graph, you can. Right 3 up 1. Is that there? No. Left 3 down 1. 1, 2, 3, down 1. I like that. This one, though, also goes left 3 and down 1. So the question is the base 2 or is the base 3? What if we find the x-intercept of each of these? We know it should have an x-intercept of negative 1. How do you find an x-intercept? You set y equal to 0. So in order to solve this, I would have to get rid of that 1. And then I would have to translate. The base of 2 raised to the other side, which would be to the first power, equals x plus 3. And when I solve for x and subtract 3 from both sides, what's my x-intercept? -1. So I like that one. The other one, if I look for the x-intercept, and you can just watch me do it quickly, and it should not work. If I add 1 over, translate 3 to the first power equals x plus 3, subtract 3 from both sides, what's this one's x-intercept? 0, which is wrong. Last one here before I hand out your homework. When you're determining the domain, we can only take logs of what? Positive. So this has to be positive, meaning it has to be greater than 0. And then you just solve that. Add 4 to both sides, divide by 3, and your domain is that x has to be greater than 4/3. So 4/3 to infinity, with a parenthesis around the 4/3 because you don't want to include it. Anytime you're asked to find a domain, take whatever you're taking the log of